The unusual trajectory of this object offers the possibility that it might have been designed so as to have some goals of a reconnaissance mission.
3. I-Atlas just whipped past the sun, and this close call exposed something wild about this interstellar visitor that has everybody scratching their heads. If this thing is really a comet, then it might be the weirdest comet humanity has ever laid eyes on. And if it's not a comet, then the truth is about to hit us hard, because 3I Atlas is now heading straight toward our side of the solar system next. And here's where things get even more suspicious. The timing of its arrival couldn't be crazier, because it showed up during solar maximum, the one moment every 11 years when the sun turns into a straight-up powerhouse. Right now, the sun's surface is exploding with massive storms, solar flares, and those wild coronal mass ejections. Basically huge blasts of the sun's atmosphere getting launched into space like cosmic cannon fire. A bunch of those solar blasts have been slamming into Earth, which is why people across the planet have been seeing insanely bright and colorful auroras lighting up the northern sky all through 2025. Those glowing skies? That's literally the sun's particles crashing into our atmosphere, and it's been happening non-stop. Solar maximum kicked off back in October 2024 and usually lasts about a year, so we're just now sliding off the peak, right as 3I Atlas makes its dramatic approach. And for any comet, interstellar or not, the most intense moment of its whole journey is always when it gets closest to a star. That moment is called perihelion, the point where the object and the sun are practically face to face. During this phase, the object gets blasted with heat, radiation, and those same charged solar particles that create the northern lights. All that energy is hammering 3I Atlas right now. And up until this moment, 3I Atlas has been nearly impossible to study because it stayed so far out in the dark. But now that it's finally entering the most extreme part of its journey, we're getting our first real chance to see what this mysterious traveler is made of. NASA just dropped a brand new image earlier this week, and it's the sharpest, closest photo we will ever get of 3I Atlas. This shot came from a satellite orbiting Mars, catching the object at the nearest distance it will ever pass by any planet in our whole solar system. Everyone expected this to finally give us some real clues about what 3I Atlas actually is, maybe even crack open the mystery once and for all. But check this out. The photo turned out to be nothing more than a blurry, glowing white dot. It's not exactly the dramatic reveal people were hoping for, and sadly, it didn't expose any huge secrets. But don't go anywhere, because the real plot twist hits in just a moment. You've probably heard people saying that we couldn't see 3I Atlas when it swung past the sun because Earth was stuck on the opposite side of the solar system. And yeah, that's mostly true. But there were a couple of exceptions that kept eyes on this thing. 2 satellites orbiting Earth are built with special telescopes designed to stare right at the sun without burning out their sensors. The trick is simple but genius. They use a circular disk to block the sun's blinding center, lining it up perfectly so only the outer layers of the sun become visible. That's how we get a clean view of the solar atmosphere, known as the corona. These coronagraphs help scientists watch solar weather, track solar flares, and capture those explosive coronal mass ejections. But they also let us spot anything lurking around the sun's edges. So thanks to the coronagraphs on board the American GOES satellite and Europe's SOHO satellite, we were able to watch exactly what happened to 3I Atlas as it pushed through its perihelion. And the very first thing we noticed on its approach? A sudden, dramatic spike in brightness. 3I Atlas started lighting up like it had just stepped into a cosmic spotlight. Yeah, you'd expect something getting closer to a star to shine a little brighter. But what 3I Atlas did was way beyond normal. This wasn't some soft glow-up. This thing suddenly exploded in brightness, becoming nearly 400 times brighter than it was just a few days earlier. A regular comet passing the sun might brighten somewhere between 10 and 100 times depending on distance. But what 3I Atlas pulled off was on a whole different level. And the brightness wasn't the only thing acting wild. It switched colors again. When astronomers first spotted 3I Atlas back in the summer, the light reflected from it leaned heavily toward the red end of the spectrum. That doesn't always mean a comet would literally look red to the naked eye, but scientifically, the data showed the reflection was strongest in that red range. That's super normal for comets, since they're wrapped in clouds of dust and gas called the coma, which usually reflects red light pretty easily. So yeah. The red tone was one of the few things that made 3I Atlas seem like a normal comet. But then early September rolled around, and out of nowhere, it flipped to green, and nobody has figured out why. Scientists are still scratching their heads, but the story gets even crazier, because as it moved closer to the sun, it shifted again, going from green to blue. And that is seriously strange. A natural comet, when heated and blasted by solar energy, would normally shift toward more red, not jump completely across the spectrum in the opposite direction. Here's the deal. Green sits right in the middle of the color spectrum. For this thing to go toward blue, it had to move in the totally unexpected direction. Now, when you mix the massive brightness explosion with this bizarre color shift, there are only a couple of natural explanations that even make sense. One possibility? 3I Atlas suddenly blasted out a huge cloud of bright blue gas. We don't know what type of gas that would even be, because nothing common from a comet produces that color. But that doesn't automatically make it something unnatural or artificial. The second explanation. This could be the early stages of a breakup event, meaning the sun's heat might have started tearing 3I Atlas apart, and what we're seeing is the beginning of it cracking into smaller pieces. A comet breaking apart near the sun isn't shocking at all. Plenty of them snap, crumble, or split as they swing through the inner solar system. But that's not what happened here, because we've already watched 3I Atlas come out the other side completely intact. So the breakup theory doesn't hold up this time. Which leaves us with a third possibility, and you might want to tighten that tinfoil hat for this one. If 3I Atlas has shown any sign that could point towards some kind of alien engine tech, this would be the moment, because whatever caused that shift didn't come from the sun. It came from inside the object itself. Sure, it could just be some weird gas release, but then we still have to explain what 3I Atlas pulled off next. Right after that bright flash of blue light, the object changed its path. As it entered perihelion, 3I Atlas suddenly started experiencing non-gravitational acceleration for the first time, meaning it began moving under what looks like its own power. And this thing wasn't crawling, it was moving fast. Now here's the important part. The sun's massive gravity well will always speed up or slow down anything that gets close. We can calculate that stuff with no problem, but any movement that doesn't follow those predictions, that falls into the category of non-gravitational acceleration, or NGA. And when an object begins moving in ways gravity alone can't explain, faster, slower, sideways, diagonal, whatever, that means something else is pushing it. Now, to be fair, comets can show small amounts of NGA during perihelion. That's normal. As gas shoots out from their coma, it acts like mini thrusters, nudging them around a bit. So the idea of 3I Atlas experiencing some NGA isn't strange at all. But here's where things stop being normal. Unlike most comets that wobble and drift as gas shoots off them, 3I Atlas stayed locked on a perfectly straight course throughout its entire trip toward the sun. It barely showed any measurable NGA for months. Not a wiggle, not a drift, nothing. That alone is rare because basically every natural comet starts getting knocked around as it heats up and forms its tail. But the moment it hit perihelion, it suddenly jumped into a level of extreme non-gravitational movement we've never seen from a natural object. The shift wasn't slow or gentle. It was sharp, immediate, and completely out of line with anything a comet should be doing. No comet ever recorded has shown an acceleration as wild as what 3I Atlas pulled off. On October 29th, the day it got closest to the Sun, scientists watched it suddenly shift 135 kilometers sideways away from the Sun and pick up an extra 60 kilometers of acceleration relative to the Sun. Put together, that's roughly 200 kilometers of non-gravitational acceleration per day. So what does that really mean? Let's line it up with the closest thing we've ever seen, the interstellar Comet 2, I/Borisov. That one showed around 100 kilometers per day of NGA, meaning 3I Atlas is doing double the amount. And if we compare it to a legendary solar system comet like Hale-Bopp, huge size, tons of outgassing, super active, Hale-Bopp still only showed about 1% of the NGA that Atlas is displaying. That's not just unusual, that's unheard of. So now we've got an object that the Sun made brighter, bluer, and way faster than anything in its category, already enough to raise some eyebrows. But then it hits us with something even crazier. Here's a photo taken on November 8th, just days after its closest pass with the Sun, and what we're seeing is not a normal comet structure at all. In the middle, you've got that bright halo surrounding 3I Atlas, stretching out nearly 500,000 kilometers in every direction. But shooting way beyond that halo are 7 distinct jets of gas blasting straight into space. Most of these jets aim away from the Sun, which isn't shocking, but a couple of smaller jets are firing directly toward the Sun, which is definitely not typical comet behavior. Normally, comets form a smooth, consistent tail. Look at Hale-Bopp again. It had 2 clean structures, a dust tail and a gas tail. Gas is lighter, dust is heavier, but both travel in the same direction, away from the Sun. That's how it's supposed to work. But 3I Atlas? It went from having almost no tail at all to suddenly blasting out 7 separate jets, some toward the Sun, some away from it. That's not just unusual, that's straight up bizarre for a natural object. And here's another twist, making scientists stare even harder. These jets are extremely sharp and well-defined, even though 3I Atlas is spinning once every 16 hours. A rotating comet should smear those gas jets into wide arcs or spirals, not leave them looking like clean focused streams shooting from the core. If these were just random bursts of gas leaking off the surface, the object's rotation would have smeared everything together into one messy, blurry tail like a normal comet. But somehow, these jets on 3I Atlas were strong enough to hold their shape, even while the whole thing was spinning like a slow cosmic top. That's wild on its own, but the weirdness didn't stick around for long. Check out the next image of 3I Atlas taken just one day later, because now it looks completely different again. Those small, sharp jets have fused together into one gigantic plume of gas. It sort of resembles a classic comet tail, but at the same time, it totally doesn't. Instead of stretching out into that wide, hazy, fan-shaped trail we expect, the tail coming off 3I Atlas looks more like thick smoke rising from a massive fire. And this plume is no small puff either. It's blasting away from the Sun and reaching almost 3 million kilometers in length. That's an insane structure to appear in only 24 hours. But it gets even more interesting. Look closely and you'll spot a second plume of gas shooting out in the opposite direction, an anti-tail. This one is shorter, around 1 million kilometers long, and it's firing right toward the Sun. And you might remember, back in the summer, one of the earliest strange behaviors from 3I Atlas was the appearance of a sun-facing emission, a type of anti-tail almost no comet ever produces. But back then, the object was still way out between Mars and Jupiter, far from the Sun's strong heat and energy. Now, though? 3. I Atlas is deep inside the inner solar system, still riding close to the Sun after perihelion, and somehow it's pushing out another huge, sun-facing plume, even with intense radiation and solar wind blasting against it. That's something a normal comet simply shouldn't be able to pull off. Here's why that's so weird. The Sun doesn't just shine and heat things up. It also fires off constant waves of radiation, creating a solar wind that blows outward through the solar system. That wind should push everything away from the Sun. That's why comet tails always point the opposite direction. But 3I Atlas? It's basically fighting through that pressure and still spitting a massive plume toward the star. And the craziest part? Even after losing millions of kilometers worth of gas and dust in these giant twin plumes, the object hasn't cracked or broken apart at all. For a natural comet, that kind of stress should shatter it. So whatever 3I Atlas is, it's built tough. Extremely tough. This is where the size debate heats up. Scientists have been going back and forth about how big the actual solid object is under all that gas and dust. Conservative estimates say maybe 5 kilometers wide, possibly smaller. But other measurements suggest something more like 10 kilometers across. And honestly, based on everything we've watched unfold, the larger estimate is starting to look way more believable. That puts 3I Atlas at nearly 20 times bigger than the first interstellar visitor, Oumuamua, and about 10 times larger than the second one, 2I/Borisov, which was already considered huge for something drifting in from another star system. And here's the wild part. When an object gets this big, the odds of it surviving a trip through deep space for billions of years without smashing into anything drop fast. A small chunk of rock? Sure, it can slip through the galaxy unnoticed. But something this massive, the chances get slimmer and slimmer. And yet somehow, this monster not only survived that journey, it just so happened to swing past our sun at the exact moment in human history when we actually have the tech to detect it, study it, and realize it's not from around here. That kind of timing is straight up 1 in a million. So no matter what you think, 3I Atlas really is a rock, a bizarre comet, or something way more advanced. It's without a doubt one of the most unique objects humanity has ever seen. That's why NASA's scientists are going all out right now, digging through every scrap of data they've collected. They've got spacecraft scattered across the solar system, all tracking this thing for months, measuring, scanning, watching every move. And now they're trying to piece together the real story hidden inside all that information. But that process isn't quick, and it definitely isn't simple. Luckily, we've got another huge moment coming up. On December 19th, 3I Atlas will pass closer to Earth than ever before. And when that happens, every powerful telescope we have on the ground and in orbit is going to lock onto it again. And honestly, there's no telling what new surprises this thing might reveal. Whatever shows up next is something you'll definitely want to catch. So drop a comment, hit that like button, smash subscribe to the StellarDrift channel, share the video, and I'll see you on the next one.